Did you know that the term IoT was first coined way back in 1999? And even before that, the first documented use of a network connected device was a soda machine in the 1980s? And now, IoT is so commonplace that it's made its way out of the realm of consumer electronics and into the world of industrial machines. And not only that, it has encouraged a new revolution. Industry 4.0 has completely changed how the world works. But how does Industry 4.0 work? Well, that's what we're talking about today. Hi, I'm Amelia Dalton, host of Chalk Talk. In this episode of Chalk Talk, Mohiuddin from Eaton and I explore the components, communication protocols, and sensing solutions needed for today's growing IIoT infrastructure. We take a closer look at how Eaton's circuit protection solutions, magnetics, capacitors, and terminal blocks can help you ensure the success of your next industrial Internet of Things design. And before we get started, don't forget to click that link. There you can find even more information about this topic from Eaton. Hi, Mohammed. Thank you so much for joining me today.
Thanks for having me.
Absolutely. Okay, so we're talking about IIoT today. But before we dig into the details, what all will we be covering today?
In this discussion, we will explore several key attributes of Industrial Internet of Things or IIoT and examine the differences between IoT and IIoT. Additionally, we will look into the comprehensive assistance and resources provided for Eaton Electronics' diverse range of products.
Okay, so let's start at the top, Mohammed. How do you define IIoT?
It is termed as Industry 4.0. It is widely recognized as the fourth industrial revolution. As a quick reminder for our audience, the first revolution saw the introduction of steam power in textile industry and steam engines. Second revolution marked a period of scientific and technical breakthroughs, while the third revolution witnessed the conversion of analog world into digital with the advent of transistors and microprocessors. IIoT encompasses various industrial domains, including manufacturing, warehouse management, machine health and performance monitoring, transportation, agriculture, and many more. Through an array of mechanisms such as machine learning and advanced analytics, the data generated by IIoT is transformed into valuable and actionable information. This invaluable insight serves as the core of IIoT, empowering organizations to enhance product quality, optimize energy utilization, and ultimately achieve efficient resource management. Real time awareness of machine operations and health significantly diminishes the need for labor intensive manual inspections of equipment. Implementing preventive maintenance strategies mitigates operational downtime, resulting in improved productivity and efficiency. In addition, IIoT offers improved safety and security and the establishments of accident-free work environment as supplementary advantages.
Okay, so what kind of components are we talking about here?
So IIoT refers to a system of interconnected devices that gather and analyze data, enabling intelligent control of machines and environments within an industrial setting. From a physical perspective, IIoT comprises a variety of elements such as sensors, actuators, computers, servers, and communication links that work together to enable data collections, remote control, and seamless connectivity in an industrial environment. Communication links play a critical role in IIoT, serving as the conduit for data transmission between devices. These links can be either wired or wireless, and they facilitate the transfer of data within the network. The nodes are essential building block of IIoT as they enable objects to be transformed into smart objects. These nodes can be retrofitted onto existing objects or integrated into objects during manufacturing processes. Nodes may possess ample processing power to make local decisions and control the objects within the IIoT network. Only metadata and exceptions are typically transmitted to the central repository, resulting in minimal data transfer and reduce congestion on the communication link. This localized processing approach helps optimize bandwidth and reduces the load on the communication link, making it more efficient and less congested. In scenarios where edge devices have limited processing power and resources, they may depend on central computer for decisions making, which can be local on-site computer or remote server or cloud. In such cases, significant amount of data transfer occurs between the central computer and the edge devices. This can result in easier communication links. Hub or gateways in IIoT setup are often serve as intermediaries, collecting, organizing, and forwarding data between the edge devices and the clients or central repository. These hubs or gateways can perform data aggregation, filtering, and protocol translation tasks, helping to streamline the flow of data and ensuring that relevant information is efficiently transmitted to the appropriate destination for further processing or analysis. In many IIoT deployments, the focus is on automatic data collection and processing with minimal human intervention. However, there are some exceptions where human interaction is required, such as livestock tracking and monitoring. In these cases, the nodes or sensors may be passive and rely on human intervention to collect and transfer data to a central location. Regardless of whether the data is manually collected and transmitted or automatically transmitted in IIoT deployments, ensuring the security of communication link is essential. Techniques such as encryption, obfuscation, frequency hopping in case of wireless communication, and other security mechanisms can help protect data during transmission, guarding against potential cyber threats and ensuring the confidentiality, integrity, and availability of the data.
So, Mohammed, there are quite a few topologies for IIoT designs, but what kind you choose is dependent on a lot of different factors, right?
Correct. The formation and configuration of communication link in IIoT deployments are critical aspect to consider. The connectivity and communication architecture play a crucial role in overall performance, reliability, and security of an IIoT system. Properly establishing and managing communication links is vital for ensuring seamless data exchange between edge devices, hubs or gateways, central computers, or cloud servers. IoT network topologies, similar to computer network topologies, play a crucial role in determining the connectivity and communication structure of an IIoT system. Connecting a few sensors and machine in a network may seem straightforward, but as the number of nodes increase to hundreds or thousands, choosing the right network topology becomes essential and requires careful planning and layout. The selection of an appropriate IIoT network topology depends on various factors, such as the size of the deployment, type of devices and sensors involved, communication requirements, scalability, fault tolerance, and the overall system architecture. Different network topologies, such as a star, mesh, tree, ring, or hybrid, offer different advantages and trade offs in terms of communication efficiency, reliability, scalability, and fault tolerance. For instance, in a star topology, all nodes are connected to a central hub, which simplifies connectivity and management, but may introduce a single point of failure. In a mesh topology, each node is connected to multiple other nodes, offering redundancy and fault tolerance, but may require more complex routing and management.
What about the different communication protocols? How do they compare?
So there are numerous communication protocols available in the world of IIoT. Here we highlight a few of the more widely known protocols and provide an overview of their key attributes. Interoperability is crucial in an IoT network where all components must communicate in a common language, while proprietary protocols may be suitable for smaller setups. For larger networks, it is advisable to choose established protocols to ensure seamless communication and compatibility among different components. Furthermore, different edge devices from various manufacturers may be used, which may not be running the preferred protocol or may not be easily customizable. In such scenarios, a hub or gateway can be customized to support multiple protocols, allowing for seamless integration of diverse edge devices in the IoT network. Let's now delve into a few protocols that are common for IIoT networks. Bluetooth and Bluetooth Low Energy protocols are widely recognized in the consumer space, while Bluetooth Mesh was introduced in 2017 as a protocol to support networked devices. Zigbee, a wireless mesh networking protocol commonly used in industrial and smart home applications, known for its low power consumption and ability to support large networks. Wireless HART is a protocol commonly used in industrial environments for wireless communication in process automation and control systems. MiWi is a wireless communication protocol developed by Microchip Technology for low power, low cost, and short range communications. It is commonly used in wireless sensors network and other IoT deployments. NB-IoT, or Narrowband Internet of Things, is a cellular communication protocol designed specifically for IoT devices. It provides low power, wide area coverage for connecting devices over cellular networks, making it suitable for long range and low power IoT applications. LoRaWAN, or Long Range Wide Area Network, is a wireless communication protocol that is designed for long range, low power IoT deployments. It utilizes LoRa modulation technology to enable communication over long distances, making it suitable for applications that require extended coverage, such as smart city solution, agricultural monitoring, and industrial automation.
Okay, so Mohammed, can we back up a bit? How does IoT compare with IIoT?
Certainly. Here's a comprehensive comparison between IoT and IIoT. We will highlight only a few. So, impact. IoT serve as the foundation for industrial IIoT or industrial IoT. IIoT provides real-time monitoring and data collection capabilities that contributes to the smooth operation of production processes, aligning well with the just-in-time philosophy of the supply chain. Area of interest. IoT is typically used in general applications where IoT is designed with greater robustness and resilience to meet the specific requirement for industrial environments. Connectivity. IIoT often requires persistent communication links for reliable and secure data transmission, while IoT may rely on consumer grade networks. Data volume. IIoT deals with large volumes of data generated by industrial machines and processes, while IoT may involve smaller data volumes from consumer devices. To summarize, the design of IIoT is tailored for mission critical systems that require strong security, precise timing of data transfer, privacy, and ultimate reliability. Here is a fun fact about the beginning of IoT. The initial use of a network devices was a soft drink vending machine conceptualized by David Nicholas, a graduate student at Carnegie Mellon University in Pittsburgh, Pennsylvania. Along with his fellow students, Nicholas devised a way to determine the availability of soda cans in the vending machine before making a long walk to its location. They use ARPANET to network vending machine, granting access to around 300 computers.
I love that. Now, Mohammed, can we get into some of the details of these kind of designs?
Sure. Here is a block diagram of an IIoT node, which can be customized based on specific requirements. The components in the node are similar to those used in electronics design. For instance, circuit protection is crucial for ensuring the safety of electronic circuits, and magnetics play a role in maintaining noise-free power and communication design. Additionally, supercapacitors can be utilized for backup and auxiliary power, providing an ideal solution. Earlier in the presentation, we showed this block diagram, and in the previous slide, a block diagram of IIoT node was shown. I like to highlight that Eaton Electronics offers product that can be used for designing IIoT nodes as well as hubs, computers, servers, and other electronics.
Fantastic. Now, Mohammed, can we look into the circuit protection solutions you mentioned earlier? What does Eaton offer in this space?
Eaton Electronics provide a variety of overcurrent protection options, including surface mount, through-hole, and cartridge fuses. These fuses are available in single-use and multi-use variants to suit different requirements. Similarly, a range of overvoltage protection products are also available. These include ultra-low capacitance polysurge devices for protecting mega and gigahertz communication lines. For power electronics and system operating in low frequency ranges, Eaton provides TVS, MOVs, and MLVs in discrete and array formats to protect against overvoltage events.
So, what about the magnetics you mentioned?
Eaton Electronics offers a variety of inductors, transformers, and DC to DC converters to meet the power, signal integrity, and common magnetics requirements. The DC to DC converters are available in both isolated and non-isolated classes, providing versatile options for different design needs.
Fantastic. Now, I believe you also mentioned capacitors as well. Can we take a closer look at those solutions too?
Certainly, a comprehensive range of supercapacitors that are suitable for backup or auxiliary power. The offerings include coin cells, small and large cylindrical cells, two cells and multi-cell modules with built-in balancing circuit, hybrid supercapacitors, and supercapacitor systems. These options allow for flexibility in selecting the right supercapacitor solution based on specific power requirements and system design considerations. Recently introduced a diverse range of film capacitors to cater any application needs. These capacitors are available in different types, including DC link capacitors, AC filter capacitors, pulse or snubber capacitors, and EMI suppression capacitors. This wide selection of film capacitors allow for tailored solution to meet specific performance and functionality requirements for a system.
So, what about the sensing solutions you talked about? What do you guys have for me here?
A wide range of PTCs and NTCs in various form factors to suit different applications. Additionally, surface mount resistors and through-hole transformers are available for AC and DC current sensing requirements. These components offer reliable and accurate performance for current sensing applications in any system. The terminal block product line includes single row standard and Euromag terminal blocks, edge connectors, and feed-through connectors. These components are designed to provide reliable electrical connection and connectivity solutions.
Great. Now, Mohammed, if my audience needs more information or further technical resources about this topic, where should they go?
An option to obtaining Eaton Electronics products is through Mouser, a distributor that offers a comprehensive selection of Eaton Electronics components. Mouser typically stocks a wide range of Eaton Electronic products, making them readily available for immediate delivery, allowing for convenient and efficient procurement. Please also visit eaton.com/electronics to access a variety of helpful tools and publications. These resources include parametric search, cross references, supercapacitor calculator, as well as user guides, white papers, and data sheets, which are all available on demand. Eaton Electronics provide these valuable resources to assist with product selection, design, and application requirements, making it easier to find the right components for your IIoT projects and other industrial and commercial applications.
Excellent. Well, Mohammed, I think that's all I have time for today. Thank you so much for joining me.
And thank you very much for the time spending with us. If you have any further questions or need additional information, please feel free to contact us at elxtechsupport@eaton.com.
And before we go, you didn't forget to click that link, did you? There you can find even more information about this topic from Eaton. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. You can't miss it, it's right across the top. Or head on over to YouTube, youtube.com/